go viral?
That might attract the crowd.
I don't think anybody wants to miss
We're on the same page.
it. And you don't want to.
Welcome everybody to Midwest House Day 5, I believe. It's hard to remember at this point. I've got a short panel for y'all today. A couple of friends of ours back from Michigan. Title of the panel is How Real-Time Education Will Shape the Metaverse. And really excited to have Jeremy Nelson and Heiko, remember your...
Heiko Winsel.
Heiko Winsel with us. Yeah, I'll let him take it away.
Thank you. Appreciate it. Appreciate the opportunity to talk with you all today and share what we've been doing and where we see things going. So I'll jump right into it. My name is Jeremy Nelson. I'm the director of an extended reality initiative at the University of Michigan, where we're focused on XR for teaching and learning. And so some of the things we've been doing over the last 3 years, I'll share with you today. We had 3 main goals when we started out: to bring XR technologies to the on-campus curricula for all 19 schools and colleges in the Ann Arbor campus, to integrate these technologies into the online space, and then to create innovative public-private partnerships, which we'll explore more today with our friends from EPIC. Some of the things that were happening at Michigan early on, which were pretty exciting. We had a faculty in the film, TV, and media program that built a VR simulation for students to go film the last scene of Citizen Kane. So they recreated the last scene of the movie, motion captured an actor. We have cameras that look like from the period, because we actually have a Orson Welles collection on campus, so we had photographs from the set and which lenses the cinematographer used. So students can now go into a headset, kind of film the last scene of the movie, and then export those clips out and re-edit them and mash them up to turn in their assignment. They can do things like put the camera in the ceiling or put it in the floor and do things you can't do in real life. We have folks in the medical school that are using HoloLens to help with ward rounding. So in peak COVID, a lot of students weren't able to go into the patient rooms. So we had a physician wearing a HoloLens, and then the students were able to join a Teams call and participate in that session with the physician. And in the headset of the physician, they can see the medical record, CT scan, x-rays, things like that. And then kind of on the other spectrum, we had an English professor teach a course called The Novel and Virtual Realities. So her perspective was that novels were immersive technologies. Hundreds of years ago, you just had to use your mind to build the worlds. Now that we can build those worlds for you, what does that do to perspective taking? What does that do to storytelling? So pretty interesting. We have an XR curriculum on campus. We have a graduate certificate program that anyone in a master's program can earn a graduate certificate in extended reality. They have to take additional 12 credits. They have to do a capstone project, an internship, and they can take varying courses from 12 of our 19 schools already. It's a pretty unique opportunity there. We have an open course that's available on Coursera, a massive open online course called XR for Everybody, really broken into 3 sections about the knowing, doing, and shaping the future of XR. So we're able to do some pretty interesting production here. So this is our professor, Michael Niebling. He's in virtual reality. We're mixed casting him, and he's teaching about kind of the virtuality continuum about augmented reality to virtual reality. So he's using an application called TiltBrush and teaching that lesson in VR. So it's pretty interesting. We created a podcast of all the faculty that are doing XR-related stuff at Michigan. It's out on the major podcast platforms. So we talk to folks from engineering, nursing, dentistry, some alumni that are out working in this space. So that was fun, kind of short 15 to 30-minute podcast episodes to hear what folks are doing at Michigan. The approach that we took to help seed these projects into curriculum was we took a seed fund approach. So we had funding, and faculty pitched us on ideas on how they'd want to use the technology in the classroom. And so that's good in academia because they don't have to take budget out. So we had money, we're able to fund projects through kind of in-kind support and or funding. So we had 2 full-time developers, and we weren't sure what we were going to get, so we ran 2 rounds of funding, and we've received 33 proposals from 12 of our schools. We funded 24 of them from 11 of the 19 schools. So a lot of interesting, diverse sets of projects from architecture. And so I'll talk a little bit about those now here in a second. But one of the ways we were able to make that happen with the generous support of our colleagues from Epic Games, we won an Epic Games mega grant to hire reality. They just don't call it that. And so they're able to help us work through creating a lot of our projects. They have real world experience. 4 big VR projects. We built a chemotherapy simulation for nursing. We built a VR physics lab to replace the physics lab that was on campus. We rebuilt the Ford nuclear reactor that was an active reactor on campus for over 50 years. It's been decommissioned. We're not going to build another one. We're not bringing that back, but we're building it in VR so we can do interesting things. And then we built a construction architecture application. So the faculty teaches students how to build with steel, glass, concrete, wood. And so they're able to go in, they have a lecture, and then they're able to go into VR and explore these pavilions and try to understand the material a little bit better. So the chemotherapy simulation is called Getting Under the Skin. So they actually learn how to place a port and what can happen when that port placement goes wrong, because there's some pretty horrific side effects that can happen when the medication is not delivered properly. So that runs on a Quest. In the nuclear reactor, we can do interesting things, like students can go run simulations. They can go into the reactor core and see what's happening at that level that they wouldn't be able to do in real life. So that's pretty interesting. It was pretty amazing. We had 2 freshman students do all the 3D modeling of the reactor based on some blueprints and photographs of the space. So it was an interesting collaboration of the students getting to build and getting experience kind of working in these 3D tools to help create something that'll be used for lots of nuclear engineering students. And then the physics laboratory, we were able to, and the first lab was to launch projectiles. And so we launched rockets on Earth and Mars and the Moon. And then the one cool technical problem we had to solve was, how do you get the data out of VR? So they still wanted the students to collect their lab results and then go graph them and do the calculations outside of VR. Obviously, we could do them all right inside the application. So we were able to figure out how to do authentication to the university system where it connects to their Google Drive. And so when they're done with their experiments, all their data gets dropped into a Google Sheet that they can go access outside. And then here's the construction architecture application. So they're almost like huge museum pavilions. There's 5 of these pavilions, and there are little design experiments within each one that they can go around and work with. So we had 2 graduate architecture students that did all the modeling and all the texturing, and then they worked with our team for the interaction design, the learning design, and how to make this a useful experience for students. So we ran a second round of funding. Last year we funded 14 new projects. This time faculty had to bring a commercial authoring tool to their proposal. We didn't have capacity to build more apps for them. And so there were a few HoloLens projects, a lot of 360 video projects. We were able to find a tool that allows us to create interactive 360-degree video experiences. So you can add, so you see an example over here. This is for an English Language Institute. So non-English speaking students can go practice having conversational English. And so the application has voice recognition built into it. And so you can practice saying the phrases, and it will recognize if you said the right phrase and kind of branch you through a narrative. So we like that because there were more options for faculty to use traditional video production skills, which we have a lot more people that know how to do that on campus than currently know how to build with game engines. But we're working on that, right, Heiko?
We get there.
We had some students recreate our DIAG, which is the center of campus, in 3D. And so we've been able to bring that to the AltSpace platform and kind of the foundations of what our contribution to the Michigan Metaverse is going to be. I will play a quick video here. So this is about the students that did all the work here. Let's see if it comes through.
The DIAG really represents the university. It represents campus. It represents our community.
Because it's the crossroads of everything.
There's been so much loss in this pandemic. I think for here at the university, for students, staff, and faculty, the DIAG is the center of campus. We wanted to give that back. So I proposed recreating the DIAG in 3D.
I love it, I love it, I love it. It's beautiful.
This is really well done.
Our day-to-day process was really based on trying to recreate an individual building at a time. So what that would involve is going and gathering reference images, map data, and 3D models to then build on top of.
Oh, wow.
The idea of creating a space where people could gather and share ideas
It's so inspiring to see what's happening here in Michigan.
was a very exciting idea to me.
I met people from London, from Ecuador. I met somebody from Jordan.
I'm based in the UK.
Creating an environment in a digital space is interesting because it can bring together new communities of global learners that may never be able to come to campus.
We recreated it as truthfully as we could within our constraints, and it felt right. It felt to me that I was on campus.
It was a wonderful feeling to be back, to really just be together again.
Seeing other people experience it for the first time, it gave me this very, very overwhelming sense of accomplishment.
I think the DIAG is the most important symbolic place we have. Having it available virtually is a great way to reconnect and helps me feel a little bit more connected to the place that I love.
All right, so that should be coming soon. We're working on a project to roll that out broadly to everyone at the university. And one of our key, I guess I'll say a keystone projects was working with our School of Nursing faculty. So they approached us about challenges they're having, retaining and hiring faculty to teach all these nurses. There's a huge nursing shortage in the US and globally. So they wanted to find a way to help train more students, more people, with this technology. So we looked at what they were trying to do. So they do a lot of simulation-based training with mannequins in their sim center. And right now it's a lot of time for faculty to kind of sit with each student and teach them how to do these procedures. And so we had a number of HoloLens 2 devices. And so we set them up with a Microsoft application called Dynamics 365 Guides that lets you create step-by-step instructions and project those for the learners. So they were actually able to put a QR code next to a mannequin. So I'm going to show you a video here of a student doing a lumbar puncture and the headset walking them through how to do that procedure. So they do it self-directed, self-guided process. So they see these holographic images telling them where L3 and L4 are and what they should be doing, and then we're able to put in a hologram of the spine and kind of show them where they need to place the needle so they can practice that. So they get both kind of the tactile, hands-free experience, and then they can also kind of see what they should be doing and guide them through that. So it shows them which needle to pick up from the tray and then where to place that. And so there's some early study, they were able to reduce faculty time by 75% and increase student confidence by over 50% because the students could make mistakes without somebody watching them. And they felt more confident through that process because when they were done, the application says, do you feel like you could do this on your own? If they say no, it walks them through it again. And then when they're ready, they take the headset off and then tell the faculty to come over and test them. So we're looking at expanding that. We're talking with folks in London with the National Health Service about looking at ways to collaborate with them because they're looking at the same technology to train their 1 million healthcare workers across the whole country. We've made headsets available for students to check out for courses. Accessibility is still a big challenge with these devices and the applications that run on them. So we've got a process set up now where students can check them out, and that's going quite well. And then we're having a big XR Summit on April 19th and 20th, so if you're in the Michigan area, or if you want to watch remotely, we'll have a webinar talk on the 19th, and then we'll have an in-person exhibit hall student showcase on April 20th at the Michigan Union. I'll turn it over to you, Heiko.
Thank you so much. Great presentation. I love how you're integrating these new technologies into the daily life of university. We love gaming technology, help people to achieve new things. And that's a great way to interact with universities and like what we believe the future will be of how people interact with technology, how they learn with technology, how they use technology on a daily basis. And so you have to start really early to get people accustomed to the way you think in that space and how you interact in that space. I lead our automotive business as well as our HMI business in that space. I also lead our virtual innovation lab. And so let me give you a little bit of insights of how we approach the industry, why we're so keen on working with academia and help people get access to the tools that are necessary to work in the future that we see coming. If we look back on the last 2.5, 3 years, however long it has been, maybe it felt like a decade, of like not being with people, finally being back here out in the open, a lot has changed in the industry. Cloud computing has like found an acceptance like never before. So there's good things that have come out of like that forced change that we see that we can build upon now, that like help us build the next level of technology into our communities and our workforce and the principles of how we think. Artificial intelligence, well, so that they become part of everyday life, so that they're not unique and new when you leave education and then people expect you to know things that you have never heard of, which is a situation that we see in the industry overall. And then interactive and immersive technology, like we've seen in a lot of the examples that you've shown, are becoming part of the daily workforce and make jobs that have fallen out of interest favorable again. Like if you work in an industrial plant that like works with HMI interfaces and works with robots, it all of a sudden become a workplace of the future, and it might be way more interesting than you thought it was in the past. And 3D is a core component of that, right? It's incredibly powerful to visualize components that you have to work with, as you just saw with like placing a needle. Like if you get that direct feedback where something is, and we're a very visual species, right? So we interact with 3D object visual references all day long. So giving that back in the virtual space at a high quality in real time is a core component of making those new approaches work. And so human-machine interfaces has become a key component for Epic Games as a development factor. So we started bring Unreal Engine into embedded systems, particularly in cars. So we have the first 2 cars that are on the road with the Rivian and the Hummer that are actually using Unreal Engine inside the car to interact with the sensors and giving you the feedback and making it a more enjoyable experience. But we will be taking that to anything that needs a human-machine interface. Like, and you will, in the future, interact with machines. Like, there is no question that that's going to come. So how much more pleasant can we make that? How much more capabilities and visual pleasure can we add to that experience and make the development of those applications that are depending on those interfaces more useful and better for you, as well as teach the teachers of the future how to like educate with those tools and use those tools on a daily basis. And what we see in industry right now is that like the industry is far ahead of where education is. There is hundreds of thousands of jobs that refer to immersive technology or specialists in game engine technology, but so we're in a race right now to enable colleges, universities, high schools with learning about these technologies so that we have the experts in the future. And it becomes like this crossroads of mixing traditional education with the new tools to like get to the next step and make sure we have the experts that everyone's frantically looking for. So how does Epic Games come into the space? Of course, we're a gaming company to give the knowledge that we receive there from what works and what doesn't work back. A lot of things have been established with Fortnite that are beyond the conventional game principles. Crossplay has been like one of the first things, so you can be on any device, any platform, software platform, which is really important from an industrial and educational space too. You want giving and adding more capabilities with Epic Online Services and libraries to the mix that make it very easy to create applications like Jeremy has shown. Because like in the past, it was tremendously difficult to build all that 3D content. For example, if you have to build a whole city, right? That's like a tremendous distraction from possibly a tool that you want to build when it's about navigation, or if you want to test some other features that in a city you want to see how they work. Now with the tools that we're putting in the market for free, like Quixel, you can build those very easy and very cheap. Right, so Fortnite technology is a key component. We've shown that like the metaverse can work on the technology that we have today. Massive events showing that like artists can reach more people than ever. I mean, like how many can you put in a stadium? How many can you reach with the virtual world? And it changes the dynamic of those events tremendously. And it also puts ourselves into the question like, what is better, physical or virtual? How do you mix it? What's a hybrid approach? How do I make a decision of whether I go somewhere physically or virtually, and what do I get out of it? And if you compare the simulation space, on the game space, there is a tremendous overlap in capabilities what game engines these days offer in comparison to what you see in typical simulation environments. So if you take it with like the way we present it here, the only difference between simulation and a game is that like we have fun with what we do. And the rest is just too serious. But the capabilities are there, and that gives you the opportunity to use that tremendous joy and quality that comes with the learnings that we have in games into the simulation and training space. We see adoption of Unreal Engine across all industries. So I represent the automotive industry, but of course there is a direct connection with media entertainment. And if you look what has happened over the last 2 years with virtual production, which started with The Mandalorian, and now you see these virtual production stages that are pretty much replacing green screen technology and are breaking the boundaries, what you can create in real time at like incredible quality. Now take this into the university space and the experiences that you can create to teach people, to like experience things that otherwise are very abstract, and you create an emotional connection that otherwise wouldn't be possible, and it creates a way different way of like talking about diverse problems and abstract problems at a very high level that makes students then realize what they have to do. And so that's our mission in this space with the educational sector. So we're putting a lot of emphasis on like working with universities, helping with mega grants, financing projects that are around gaming technology, and make it easier to access that technology so that we have the experts of the future at our hand that we really want to see in the space. And as I mentioned before, like surprisingly, the industry is now incubating the educational space, right? So they've moved ahead with like what they want to do, how they use it, and we have to follow up with getting the educational space ahead of the game again, and like starting to innovate in that space and come up with the new ideas. And so we're super happy with the collaboration we have in that space to get to that point, so that we can bring teachers into the mix and say like, you should be using this technology to teach. There is a change. Like if you look at what happens with kids and how fast they learn video games and how intricate they create environments for themselves, and they want to learn, they want to be fast, they want to be engaged all the time. So how do you create educational tools that follow what games like Roblox and Minecraft and Fortnite have shown to be possible from a creative perspective into that space to get to the next level? Synthetic realities are a core component of that, right? Everyone is talking about the metaverse and like how well can that look like, and you see the first examples, most of them are fairly low fidelity. But what you have with pixel streaming and the ecosystem that comes with Unreal, that you should be able to create environments today that look like movie scenes. There is no reason why you can't get to that space. Not even a financial one. Like with all the free tools that are available in the market, you should be able to create stunning imagery and scenes that you can use for your educational space without a big issue. And like this image actually comes out of a tool called Twinmotion, which changed tremendously how architects can visualize their concepts and their creative art. And so we should all understand what the ecosystem is that's available to you. So whether that's our ecosystem or other ecosystems of other companies, it's really important to understand there is the tool and the technology, Unreal at the heart of it, but it has a tremendous marketplace and tools around it with Sketchfab and ArtStation that are all catered towards the creative community and helping you to get faster to the goals that you want. I would say it has never been easier to create than it is today. And I have a long history in production and like learning how to overcome hurdles, whether it's hardware or software, and like creating like photoreal images was like, that was the top end of what you can do. And now, I mean, pretty much anyone can do it.
On a laptop even.
Yeah, right, on a laptop, right? I mean, you don't need these big hardware clusters anymore. You don't need super expensive software. You're right there. So let's use it and see how far we can take it. So I think the Quixel ecosystem is a unique part of that. Like going out, scanning the world, making it available for everyone to be used is a core component there. And then using reality capture to add to that library gives you like pretty much the world to your hands to use it in your projects and play on a very high level. Right, so and Sketchfab using WebGL, so whether you stream or whether you use on-demand rendering or whether you have an offline production tool or a virtual production real-time setup, all these tools cater to all the touch points that you need to interact with different kind of client segments or situations based on hardware and software that's in the environment. So you should be able to easily build an all-encompassing tool or platform for your own needs. Right, and the last and latest past of that has been the MetaHuman creator, right? The whole conversation of having digital humans is a key component of like building those more immersive environments, talking about co-presence, getting the idea that everything that you've done so far alone when you're in the internet, you're doing now with other people. There is a social component that comes to anything, and how do you represent yourself in that system? How do you create a situation where you can transfer that avatar that you've created into other systems? And how can we create, as a technology company, a situation where it becomes easier to create those, but also to share those and bring them from one platform to the next? Right, and then, as we've shown with Fortnite, these social environments, these games can become a place of learning, like we've seen with the March and like other situations where we can react to real world events and situations and like bring it to a platform, bring it to a community that has a very unique way of interacting with each other. But now they get like within that environment the capability and the situation that they can interact with that and learn more in their own pace and like in a very unique way. And I think that particularly for universities is a unique opportunity in like making an emotional connection. Like you can recreate history, you can recreate invention and situations of like how they were done, how they work. You can go deep into a machine and understand what's happening, as we've seen with the medical, right? You can like do it over and over and over again. There is no risk until you're like perfectly adopted to see how that works. Here's one version how we're using it ourselves. So I couldn't build a physical lab. So we built a virtual lab where you create your avatar and then you have a whole campus of a virtual Detroit. It's all pixel streamed, so you just go to a browser, you set up your avatar and you start interaction in a spatial situation similar to like your DIAC campus, but on the level of current AAA games. So you can build this and then build your own brand IP campus and invite people there. And what we're seeing already is that automotive companies are checking into that principle and saying the future automotive showrooms are gonna work this way, where you bring your friends, your family, and the dealer into the space, you configure together, you talk, you have a conversation, you have a social event inside there, and then you make your decision. So that's one step further than where you are today, and it brings an immediately a return on invest, which usually is missing in the metaverse conversation, right? We need to be aware that if we want to like get to the next step, we have to create value that like is immediately there and shows like why this technology is better than what we have at the moment. And so what we see in education is that if you take this simulation approach, and I'm not going to go too deep into this, but simulation and gaming technology are very similar in the approaches of how you teach and use them in this space. And so there's a very pragmatic way of how you can like introduce game engine technology and the quality that it brings, as well as the social capabilities that come with it, into the educational and training space, and then build like the next gen of educational tools. And so, as I said in the beginning, we're seeing that across the board. And what's really interesting, when we work with high-profile creative people and give them these tools, within very short time, they can create amazing experience. And so the last thing I want to show is like what came out of the fellowship around the virtual production technologies and what people that come out of that space can create within 30 days. So they learn how to use the tool, they are creative, they know how the space works, but within very short time, they like are enabled to use a game engine, and in this case, Unreal Engine, and like create amazing content. That's for me.
30 days, that's pretty awesome. Yeah, thank you for the opportunity. Any questions or thoughts that folks have?
How do you get schools connected, or how do you suggest getting, and what disciplines are you looking at primarily when you're looking at going to different schools?
There is not primary disciplines at all. I mean, of course, there is like in the gaming space, it's very easy to find an understanding and overlap there. But we're in architecture, we're in simulation, manufacturing, like whatever it is, there is some overlap. But what we're most interested in finding those intersections. Where does it make most sense to take a curriculum that exists right now and say, how much more do you get if you add gaming technology to that, right? So if you think about a manufacturing process where you train a generation of engineers that will work with that kind of technology. So what we do is we have tremendous amount of learning material that we're totally fine that you start white labeling or reusing. If you want to work with us and build curriculums, we have a whole educational department that you can work with, and we can make a connection there. And if you're looking for, we have different kind of fellowship and connectors to like build these starting situations to show how that can work. So there's lots and lots of ways. Simplest way is to just look on our webpage and at the educational site, but please reach out and I'll make connection with our educational team.
And one other question, you're talking mostly about college level. What about some of the programs in high schools? When you get into some of that, like do you start that young, or you're still at this point just looking at the older?
No, it goes down all the way. I would say to middle school, maybe even earlier. I mean, like it changes how you teach them, right? Like the younger they get, you use more of a gamified approach. You give them a game and you teach them how you use blueprints, concepts that they can put together and make that work. But we have programs right now that are running that use the principle of cooperating with other companies, and we go in high school and, for example, use underprivileged kids and say like, hey, we'll sponsor the machines that you can keep later on, so they have a great gaming laptop, which is a good incentivization, and then we say like, you go through the course and you possibly get an internship with an industrial company that's working on that level. So there's lots of way of like changing the dynamic in that space and working with those kids. There's really cool programs that use, for example, at NASA, the idea of saying like you program a rover through a game and you learn trigonometry in a playful way while you're doing that. So there's ways to go to the younger age. But of course, when we talk about college, that's like primary the idea to like create the experts that we need right now in the space.
I'm wondering like how you all are looking at like connectedness long term. So like, you know, outside of the Unreal family, like whatever Facebook is doing, like how are you all like going to connect and share? You know, you look at like Fortnite, we're building like a coffee company in Grand Rapids. So one of the things that we want to do is like give people like a virtual coffee, you know, within whatever metaverse that they're in.
Sure.
Like how is that connectedness going to look?
Yeah, if you think back on the ecosystem that I presented, the idea is to build components that like you can share. A lot of the things that we do in Unreal Engine are based on open source to a certain extent. I mean, when you get Unreal Engine, you get the source code and you can program on it. But I think if you think about the components that you've seen, like Quixel, which is available to not only Unreal Engine, but any platform that wants to use it. The same is true with the MetaHuman creator. So we built these components that allow them to use you in whatever way you want. Of course, like just connecting them with Unreal Engine is like our preferred way, but like if you take OpenXR standards, which are really important for building like tools at university, then you're independent of the hardware, and you have a bigger reach, and that's what we're trying to teach people. Like the more open your thought principle is and the way you create these tools and the tools you use to create them, the bigger your success and reach will be. And I think if you look at industry trends right now, they've all accepted that open source is a key component to be successful, and so we use the same principle in like building those elements when we develop.
Yeah, I mean, we think similarly when we built our digital campus, I had the students create it in Blender, which is an open source 3D modeling tool. And they built it at high res, but to get it into that application you saw, we had to get the file size under 30 megabytes with an M. And so it had to get really small, so we had to, you know, stylize it quite a bit so it doesn't look like it really does. But as the pixel streaming and this technology continues to advance, like we'll be able to kind of bring it to that space. But yeah, OpenXR is a protocol that almost everybody, except for I think Apple's finally going to lean into that. I mean, it really takes the big players that, so they're, built a lot of AR. If you look at your phones and kind of where they're headed, they're laying a lot of foundation for AR. Meta is obviously investing a lot into the VR space and spending a lot to really push the industry forward. But
Yeah, and I mean, we're not building per se the service or the platform that does it for you, right? So we leave that to other companies to use our technology and build that and build business models that work. And the same is true for Meta. They can use Unreal Engine to build what they want, and they can tap into the resources that come with it, which might bring the benefit in the future that you can take a component that you've created for one and bring it to another space, right? This cross IP, if you look at how Star Wars works, or Marvel, right, you see those characters showing up in different franchises, and like it builds a bigger picture, a bigger world, a bigger connector, and so it's the same principle that you have to think about when you build your application or your business case in that case.
You showed a 4-step process, the pragmatic decision-making type thing. Where do you find the biggest roadblock, number one? And then from a university standpoint, what's the biggest challenge to get up to scale where you can take full advantage of what is offered?
Do you want to answer that? Or should I go first?
I mean, the biggest challenge for us is like content, like tools to create content quickly, right? So we're looking at ways to begin to build frameworks or, toolkits around the parts here for students to come in and create content faster, to create these experiences. That nuclear reactor took many, many months and a lot of folks. So while that's great for that program, if we really want to bring it to many more classes, we need more people that know how to do it, and they can do it faster with some standard processes. So we're trying to build that out internally, or looking at that 360 video authoring platform that allows us to just, through a browser, upload the videos and images and then create, so you don't need to know anything about programming in that case to build the experience. So I think right now it's just finding the people, kind of equipping them and showing them the path to lead forward.
Yeah, I think the biggest challenge we see is, like, if you want to put it into one sentence, is teach the teachers. Right? Because you have a community, you have almost a situation that students know more about the technology than the teachers that are supposed to take them to the next level. So how quickly can we bring teachers on the level that they understand technology, and then bring them on the level that they use it for like their daily interactions with their students, and then start to go beyond and say, like, okay, what else would I like to do? And how can I use this technology to step beyond what I've seen, or like what the conventional way of teaching is?
Do you see that gap?
Well, it's hard to say, right? I mean, it's such a short time that all of this has happened. So we definitely see tremendous interest. Like in every college, university around the world, you see interest in like getting into those gaming technologies, do more. I mean, with the Mega Grants program we have, there is a tremendous interest to help people get funded and do those things. But in the end, it takes personal investment. Right? For a teacher to like kind of leave behind the safe space and say, like, okay, I'm going to do this in a new way. But I mean, especially I think on the gaming side, there's very easy benefits that you have, right? Like going into a virtual lab and saying, like, whatever you create, you can immediately, in a collaborative way, in a multiplayer situation, evolve and evaluate with like all your teammates, is definitely something where you're going to go from a gaming perspective anyhow. For other industries to understand that principle, like this virtual collaboration and like working this way, takes a little bit longer, but it's all in the teachers. It's like the willingness to embrace going down that path and see the benefits, right? I mean, of course, the first step is difficult. You have to learn something new. But we see benefits in like once you then roll it out. Like once you have these environments that you can work with, now they scale and they bring the benefits that you want, and you might get more success, right? There are studies of like how much retention you have when you use these virtual tools versus when you use conventional means. And I think those success rates will eventually drive teachers to like go further down that path.
Can I follow up? I don't want to pause.
Sure.
So in the degree programs for teachers in education,
Yep.
is this being integrated into that as teaching methodology?
It's starting to. So in our architecture college, they're using Twinmotion and using Unreal Engine for that. At Michigan, they don't tend to teach like the actual tools. Like there isn't a class to learn how to use Unreal. Like students have to learn that outside. They learn the principles and how they use tools, because the tools are going to change and they're going to evolve. So programs like ours, where we're able to support the faculty or support the students and give them opportunities, is where that complement's been happening. And then through our online learning, so we have opportunities through our Coursera and our massive open online to teach these. You know, one of our most popular courses is Python for everybody. Like, that's not a course that's taught at the university, but 2 million people have taken it online. So I think there's opportunities there to reach both students that are enrolled, but also the global audience.
And the teachers.
And the teachers, right, yeah. Mm-hmm.
Yeah, hi. Thanks.
Hey, how you doing?
Do you find any pattern in which teachers are more receptive or which are more resistant, like either in subject matter, age, seniority, like is there any rhyme or reason to it?
I mean, it's a willingness to kind of try and fail that's been more successful. Like, some faculty don't want to make a mistake, especially when students are paying a lot of money for tuition. But others kind of have that, like, we're going to try this out. It's really emerging technology. There's going to be problems. Like, we're going to work through it. And they kind of tend to architecture and engineering and medicine, nursing. So they've leaned in the hardest. And then we've been using those examples to recruit others in that space.
Yeah, I think the creative space is, like, by definition more receptive to that, because it's like very adjacent to how they work. But as Jeremy said, like, we're in the automotive industry, and colleges that are really close with automotive companies to go there.
Just knowing it exists. So many people still don't know it exists or have never tried on a headset, so they don't. I mean, we can show you videos, we can talk about how great it is, but until you go into one of these experiences, it's hard to explain it. Yeah.
Can each of you sort of talk about moonshots around how you think this technology, in a really ideal way, could be used in education 5, 10, 15 years in the future?
Moonshots. What are you thinking?
You want to go first? Like,
I mean, what I'm most excited about these days is this whole concept of virtual production, where we can bring online learning or bring people into these environments where they couldn't normally be. Like, we're working on one, that architecture project I showed you, to bring the faculty into that environment where they're not wearing a headset, and they're now teaching in a space that they could never teach before, and kind of bring the information to students they couldn't. And then where we take that from there to how we create classes in a much more affordable, faster way. Right? It's not going to be $1 million an episode.
Will kind of merge. You will be like in a constant engagement of like learning new things because the material is available. You don't have to be in a specific space to learn, right? Like, if you can log into an immersive educational environment from anywhere without like the hurdle of like how much does it cost to get into this class, or like do I need to be in a specific city to even have access to that?
Is there enough space?
Yeah, or do I need specific hardware to like participate? And then and I can decide how long I want to learn, and then I want to play a little bit, but that play could be connected to something that I've just did to reinforce what I've just done. And then I see, and so I think that could be a tremendous change in like how education is approached in general. And then I think there's tremendous chance to like kind of re-engage in the social conversations overall, like the social concept that we have and how you converse and learn about those things, right? Like this understanding what it feels to be in someone else's skin gets like a total different component when you take the metaverse approach literally in that situation. And like you kind of get the emotional version of like realizing concepts or talking about, and like all the algorithms that can be behind there and how you can analyze behavior, likeness, and capabilities of people and what that means in that space. So education can pick up on all of those and like take a leading role in like where that should go, like what are the components of making that happen. And I think there's a tremendous chance in like taking that to the next.
Continuous, like lifelong learning, like you need this, you know, maybe not the straight matrix, now I know Kung Fu, but maybe closer.
You're talking about a whole bunch of positive things.
Yeah.
What about the bad actor scenario that takes this powerful technology and doesn't use it for the common good of all?
It's hard to answer that. Like, what is like? I mean, like, I would say there's always going to be a race between good and bad, right? And it's technology, which means like you can do one thing and then there's a reaction on the other side. I think the more you know about technology and the more you educate people about technology, the harder it becomes to do simple frauds. The more complex frauds, I think there's no difference in the physical world, right? Like a really good con artist will get you, no matter what. I think you can change that. If that's human behavior, then so be it. But I think the smaller things, you can educate people to understand what works and what doesn't work, which I think should be part of education, right? Like if you just step back, no one taught anyone of how to use the internet. Right? We just assumed that like the technology is there and let's see what happens. If education would have a more proactive step towards saying like, okay, what could we do to make people use that technology in a reasonable way, realize like what is good, what is bad, or like what potentially has some dangers, then like you have a more educated crowd that like can interact with that technology better, and therefore you have less risk. I think that's the way I would approach it. I don't know a better answer right now.
I think there's serious concerns with data protection, data privacy. I mean, with 20 minutes of virtual reality, you can collect 2 million data points on a person. What their movement is, where they are, like potential health conditions that they don't know about yet. I mean, so it could be good, but it could also be used nefariously if your business model is different. And then, harassment, which has been around in games and like trolling and that kind of thing, but it's in VR, like you feel it as like a real memory, like it happened to you. So there's just an extra level of kind of thoughtfulness that we try to teach our students as they're going out to build these experiences. Like be mindful of the data, be mindful of the experience, allow opportunities to, block people or put a bubble around you, or just other ways to engage. Because I think that's.
But there's been very interesting tests in the gaming industry is actively punished by to the gaming community, right? So you harass, and all of a sudden everything you buy in the game costs more, right? So you can like have in this world, like everything you can do can have like direct implication, and you can teach people what that means in like way more ways than in the physical world, right? You just need someone that wants to do it, right? So you can either say like, it's a problem, I don't know what to do, or you can think about how would I approach it and figure out a better way to do it.